Good morning to everyone. Last video we can see about the different types of geometries 1D, 2D, 3D geometries. How we can classify into an 1D geometry, 2D geometry and 3D geometries. Now we going to discuss about the what are the different types of 1D finite elements and 2D finite elements and 3D finite elements. That is the last video we can discuss about the structure. In this video we can going to discuss about the finite elements. From structure to we can convert into finite elements. In 1D, we can consider as trusses, cables, pipe, beam, bars, and then rigid links. So these are the different types of 1D elements available. Based on the loading conditions and applications, we can select the elements. In 2D elements, we can consider about the plane stress condition, plane strain condition, axisymmetric elements, plate bending, cell with flat elements, cell with curved elements, such kind of different types of elements available for a 2D elements. This also we can consider about the loadings and then applications. It will be varying. In 3D elements, we have classified into brick elements, tetrahedral elements and general elements. So these are the different types of finite elements based on the 1D, 2D and 3D. Next, we want to know the basics of engineering mechanics, because everything the finite element analysis will combine of engineering mechanics, applied mechanics, solid mechanics, all those things. So that's why we are recalling about the solid mechanics and engineering mechanics, applied mechanics, everything can't be minimum. Yes, the engineering mechanics, study of behavior of a body under the action of external force while the body is stationary or in motion. In this, we are going to study the behavior of body, any objects under the action of external force. If we are applying any external force for a particular object, that will be either in static or in motion or dynamic conditions. So any conditions, static or dynamic conditions, we are applying an external force. How its behavior? In already we discussed about the solid mechanics. If we apply the load, the behaviors will be happen depends on the geometry or material properties. So this will be an interlink of solid mechanics and engineering mechanics. Next, we are apply the fundamental laws and the principles of physics to study the mechanical behavior of stationary or moving bodies. In general physics, we have studied the laws and principles. In engineering mechanics, we are applying the laws or principles in an mechanical objects. That principle, based on the principle, how we can arrive the particular motions or a deformation or some other conditions. We can arrive by with help of principles and laws. This will be studying in the engineering mechanics. In applied mechanics, it transfers the theoretical knowledge of a behavior of mechanical bodies to formulate the mathematical models. We know the theoretical knowledge. In engineering mechanics, we will find about the theoretical knowledge with correlating of physics and mechanics. Here we can convert the theoretical knowledge into a mathematical model. So now we get a mathematical model for any structure. We can get as a mathematical model in an equation form. That is called as a physical phenomena. Then in this mathematical equation, the name called as a physical phenomena. For any structure, we are get as a mathematical equation that will be called as a physical phenomena of the particular objects. That will be converted into an applied mechanics. So thank you. We'll see you in next video.